Okay, we are now doing the last section of chapter 2. And this particular section, you may have worked with scientific notation, but now you are going to have to get down to the very specifics, especially if you plan to take science classes, because science and math have some very specific rules about scientific notation. Now, I know when I taught high school, we weren't as stringent as we are these days in college. So, therefore, you're going to need to understand the process of scientific notation and its definition. Now, in many science fields, we encounter very large numbers and very small numbers. Scientific notation is a convenient shorthand for expressing these types of large and very small numbers. Now, this particular sentence you may not understand very well, but you will as we go further. A positive number is written in scientific notation if it is written as the product. Product means I'm multiplying of a number, A, where 1 is less than A, less than 10, which means that A is a single digit, a one non-zero digit. Okay, and this is important. It's got to be to the left of the decimal. Now, these are the rules that you're going to find, especially in science class. This is saying, first off, step 1, find the decimal point. Now, in some very large numbers, you're not going to always find the decimal place or see it. It is understood to be in the back, like the dog's tail. And therefore, because every dog has a tail, I should say, maybe not a long one, maybe a short one, but every dog has a tail, every number has a decimal. Now, step 2, we're going to move the decimal in the original number so that there is only one digit to the left of the decimal. Now, in step number 1, I talked about large numbers. Well, what about small numbers? Well, small numbers are going to have decimals, but we're going to see them. They're out in front. And we're still going to move that decimal place so that it's behind a single digit, and it's that single digit is to the left of the decimal. And then the beautiful part is counting. You're going to count the number of decimal places between the original decimal point and where you moved it. Okay? And I should say moved it in step 2. Okay? The original number had its decimal. If it was to the right, because it's a large number, we've moved it to the left. So therefore, the exponent of the power of 10, and it's always power of 10, will be positive. If the decimal is shown for a very small number, the decimal will be to the left, and it's got a lot of zeros behind it, but we're going to move it to the right and move the decimal to the right, but the exponent for the power of 10 will be a negative. Now, when we begin this exercise, they're going to give us some numbers that don't have the problem written in correct scientific notation. And the reason they don't have it in correct scientific notation is they want you to just understand how to move the decimal wherever it is. because there are times when we do at the end of this section, we're going to get answers, but we're going to have to remember the decimal has to be to the right of a single-digit number. Now, these are some examples of what is not scientific notation, and you are going to see those. Now, notice here, it's not in scientific notation because I have 2 digits, and see that decimal? I have 2 digits to the left of the decimal point. If you look at example 2, the rule says non-zero. You can't have 0.61. That's not correct. And also, look at this 300. The decimal point is behind here. There are 3 digits to the left of that decimal point. These are all 3 examples of what is not scientific notation. But as I mentioned, in the next 2 slides, you're going to see some problems that are not written in scientific notation. The reason is they're just trying to get you to read what is happening with the powers of 10. And it simply means move the decimal place. Now, I'm going to give you some examples, and here we go. First off, problem A is written in scientific notation, so that's beautiful. Now, we want to write this number in what we call standard form, okay? This means we're getting rid of the decimal and the power of 10. If the power of 10 is positive, this decimal moves 1 place to the right, which means my answer is 95. Okay? Okay. This is known as standard form of a number. Sometimes they call it standard notation, but it's standard form. Now this one, decimal place is back here, and B is not written correctly. But notice the negative. That means we're moving this decimal place 3 to the left. Now, with scientific notation, you are going to put a 0 for standard form, and this is 0, 5, 4. This is the number in standard form. Okay? A was written in scientific notation, B was not. Okay? Now, our last example, or I should say our last 2 examples. Okay, they're not written correctly. But notice, we want to write these numbers. I have a positive 5. Well, this time, here's the decimal. We're seeing it. We are going to move 5 to the right, which means 1, 2, 3, 4, 5. It's going to sit behind the 7. This is considered standard form or standard notation. Okay. Now this one, decimal is where? Back here. It's not showing. But this negative is saying from this decimal point, we're going 7 left, which is 3, 4, 5, 6, 7. So this is 0.1, 2, 3, 4, 4, 9, 5. And if you want to check it, count it. This is where my decimal was. 1, 2, 3, 4, 5, 6, 7. This blue number is our answer. That's what they're saying to multiply. They want a standard form, standard notation number. Now, this is going to go backwards. They want you to write in standard notation. Now, okay, that means we're getting rid of the powers of 10. This is saying positive 3. Here's my decimal. I am moving it right 3, which is going to give me the number 1745. Now remember, a 4-digit number does not need a comma. If you want to put the comma, it's between the 1 and the 7. Now, here's our decimal place. But this is negative 2, which means we're going left 2, which is 0.0107. Okay? And then here's our decimal. This is positive. That means from here, I'm going 4 right, which is 39040. This is a 5-digit number. 5-digit number gets a comma. Okay. Now, okay. Now we're going to go backwards. This is scientific notation. And by the way, you are expected to write scientific notation correctly, even though in previous slides, some of the numbers were not written correctly. Now, first off, decimal point is in the back. Every large number has the decimal in the back. Now, the rule says we must move the decimal place so that there is one non-zero digit to the left, which means we have to put it between the 4 and the 8. So that's why we write down here 4.8. Now, it's always power of 10. That is not going to change. Power of 10. It's not x20, x30, it's x10. Now, how many decimal places did we move the number? Well, we moved it from back here 1, 2, 3, 4 places. That's how we get the positive 4, because the original decimal place was to the right. Okay. Now, let's see if I can show you a couple. Okay. First off, decimal point is back here. I am moving it between the 1 and the 5. So I'm writing 1.5 times 10. Now, how many places did I move it? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Positive 5. Now this one's easy. The decimal is already here, but we've got to move it so that one digit is to the left, which means we've got to put it between the 3 and the 4, which is 3.46 times 10. Now, how many places did we move it? We moved it 3, but it was given to us. So this is negative 3. And make sure you can see that little decimal point. Let's try it again. Okay. Decimal's back here. We need to move it so that there is one digit to the left. This has got to be written 1.23. Now notice I'm writing all of the digits that are not 0 because this x10 is going to take away some of those zeros. Now how many places did I move it? I moved it 8, and it's positive because the decimal was to the right. In a large number, it's always never shown, which means I have a positive exponent. Now D, okay, this time I'm lucky. It's to the left, which means on my x10, I should already know I have a negative number. And what goes in front? Well, this is 6.78. Now, how many places did I move it? 5. And the reason it's negative is this has the decimal given. We're seeing it. See, large numbers, decimals are in the back. So when we move it, our exponent is positive. When we look at the small numbers where the decimal is given and it's out in front of the digits, there's a lot of zeros behind that decimal. So therefore, we then write it negatively. Now, of course, they've got to give you some story problems, and I can tell that you really like this one. Okay, it says write each number in scientific notation. Okay, well, first off, because this is a sentence, we kind of gave you a clue. Decimal's back there. We want to move it so that it sits between the 8 and the 5. So this is 8.55 times 10. Now, how many places did we move it? 6. And it's positive because the decimal's at the end. Now, this one, notice my decimal is here. But remember the rule. We need to move it so it's behind the 3. Well, this is going to give me 3 times 10 to the negative 2. But if you look at this number, do I have a decimal point? Well, technically it's not showing. I should write it as 3.0, because remember, I want one digit to the left of the decimal place. Now, I accept this answer that I just circled in black, but Pearson likes the second answer that I'm giving you because of the rule. One digit to the left of the decimal point, which means I should have numbers after it. Okay. Now, here comes the fun part. Okay. Now, this is asking you to perform the operation. Now, the answers here are not going to always be in scientific notation. But when they ask you to simplify, they want your answer in standard notation. Now, this 3 multiplies by 8 to give me negative 24. Now, we're multiplying. We add the bases. This 6 and this 3 give me 9. Now remember, decimals back here. We are going to move it 9 to the right, which means negative 24, 1, 2, 3, 4, 5, 6, 7, 8, 9. That's my simplified answer in red. That's why we did some problems that are not written in scientific notation, so that you can translate some of these a lot easier. Now, let's take a look at this one. Okay. 6 times 9 is 54 times. Okay. This is your product rule. Negative 6 plus 13 is giving you 10 to the power of 7. Now remember, decimal place is back here. We are moving it 7 to the right, which means this is 5, 4, 1, 2, 3, 4, 5, 6, 7. And don't forget my commas. This is my simplified answer. Now, the last 2. Okay. This line means divide, which means 8 divided by 2, or 4, is 2. Now, this is your quotient rule. This is going to give me 10, 8 minus 4, or 4. Well, don't forget, decimals back here, we're moving it 4 to the right, which means this is 2 with 4 zeros behind it. This is my simplified answer. Now, this one, little interesting. Now, 5 divided by 2. You must give me the decimal 2.5. You do not want to give me 2 1/2, the fraction or mixed number. Scientific notation deals with decimals. Now, here's the fun part. This is the quotient rule, but the bigger one is at the bottom. 5 minus 9. Now, this time I have to write negative 5 for this one. The reason is I can't use a fraction. And also, scientific notation has positive and negative exponents for 10, which means that this is moving to the left 5 places. This will give me 0.12345. This is my simplified form. This has to be written as a negative exponent. You do not want to write 1 with 10 to the 5th in the positive, not with scientific notation. Scientific notation, you are going to give me the -5. Now, this completes chapter 2. Now, as soon as you finish this section, you're going to find that it's got a putting it all together, which is using all of negative exponents. Then you're going to have a chapter 1, 2 review. Those 2 homeworks, you got to try on yourself. It's supposedly helping you to take your first in-person chapter 1, 2 test, which I know you're going to be excited to take. This now ends, in this case, chapter 2. You should be able to get ready for your chapter 2 test. Catch you later.